Here's a very interesting question which was actually given in a GMAT quant exam, and it looks at an absolute value inequality. Okay, now if you'd like to see anything similar to this on the channel, or if you have any suggestions for any specific topics or questions that you'd like to see, let me know in the comments. So here's what we know. We know that x is an integer, right? And we know that this inequality is true. And then the question is, which of the following options is true? Okay, so we have choices from A to E. So my suggestion for this is to try and solve this inequality, see what x can be, and then see which of those 5 options satisfy our solution of whatever x is. Okay, so this inequality can be rewritten in the following way. So the goal here is to first of all get rid of the absolute value. Okay, and to do that we take into account that this becomes minus 2 less than 1 minus x and less than 2. Okay, and we got rid of the absolute value. So I can rewrite the inequality, which is actually like a double inequality now, and now we want to have x by itself. Okay, so the first thing I'll do is I'll subtract 1 from everywhere just to get rid of this 1 here. Okay, so on the left hand side I get minus 3, then less than minus x, and then less than 1. Okay, and the last thing I want to do is get rid of this minus. Okay, I don't like the minus x being there, so all we have to do now is multiply the inequality by minus 1. Okay, now keep in mind when you do this, when you multiply an inequality by a negative number, you also have to flip the direction of the inequality. Okay, so this now becomes x. Okay, so I'll start with the middle, which is x. Now the minus 3 turns into a 3, but this turns around, so this becomes less than 3, and this inequality here becomes, well, this also gets flipped around and becomes greater than minus 1. Okay, so that's it. So x is part of this interval from minus 1 to 3. But we also know that x is an integer. That's what the question tells us, right? This is, that's here. So if x is between minus 1 and 3, excluding minus 1 and 3, and if x is an integer, then we know what x is, right? So x can be either, so x is a number from this set. So 0, 1, 2, and that's it. So x being an integer means it can only take those 3 values, 0, 1, and 2. Okay, and just as a reminder, it cannot be minus 1 or 3 because this is an open interval, right? And the reason it's an open interval is because this is strictly less than 2. Okay, if it was less than or equal to 2, then we would have had minus 1 and 3, but we don't. So yeah, I'm gonna erase this. Okay, so that's x. So x is either 0, 1, and 2, and if x is 0, 1, or 2, then this inequality is going to be satisfied. So let's go through each of the 5 options and let's see which one is actually correct. Right, so A says x is not a prime number. Okay, so we're dealing with 0, which is not a prime number. We're dealing with 1, which is not considered a prime number. But 2 is a prime number, so A cannot actually be true. Okay, let's look at B. So B says x squared plus x is not a prime number. Okay, well, let's see what x squared plus x is. So we know that x is this, so x squared plus x is either, so if x is 0, then this is 0. If x is 1, then this is 1 plus 1, so that's 2. And if x is 2, this is 4 plus 2, and we have 6. Okay, and let's see what this says. So x squared plus x is not a prime number. Well, yeah, 0 is not a prime number, 6 is not a prime number, but 2 is a prime number, so it cannot be b either. So let's write b, and then we'll put a red x just to say that it's not b. Right, then we have this here, which says x is positive. Okay. Well, we have 1 and 2, which are clearly positive, but we have 0, which is not really considered a positive number. So yeah, it's not C either. And then what else do we have? We have D. So the number of distinct positive factors of x plus 2 is a prime number. Okay, that's a mouthful. So let's try to break this down a bit. So the number of distinct positive factors, so we have to look at how many positive factors x plus 2 has. Okay, so x plus 2 is this. So if x is any number from this set, then x plus 2 is 2, 3, and 4. Okay, we just added 2 to x and we got 2, 3, and 4. Right, so let's see how many distinct positive factors each of those actually have. So let's look at 2, 3, and 4. Okay, so 2 can be written as 1 multiplied by 2. 3 can be written as 1 multiplied by 3. And the factors of 4 are 1, 2, and 4. And that's it. Okay? So the question is asking us to look at not the factors themselves, but at the number of distinct positive factors. So the number of factors. Okay? So 2 has 2 factors. 3 has also 2 factors. And 4 has 3 factors. And this says the number of distinct positive factors is a prime number. So look what happens. The number of factors of 2 is 2, which is prime. The number of factors of 3 is 2, which is also prime. And the number of factors of 4 is 3, which of course is also prime. So it looks like D is the correct answer. Okay, so at this point, I would just circle D as the correct answer and I would just move on. But let's look at E just in case. So E says x is not a multiple of an odd prime number. Okay, so let's see. Let's write this again. So x is 0, 1, and 2. And E says that x is not a multiple of an odd prime number, of an odd prime number. Okay. Well, let's actually start with 2. So 2 is not a multiple of an odd prime number, right? Because 2 is just 2 times 1. So you can say that 2 is a multiple of 1, but 1 is not a prime number. So yeah, 2 would make E to be correct. And then if we look at 1, yeah, this is also not a multiple of an odd prime number, right? This is just 1 times 1, but 1 is not a prime number, so there's that. 0, on the other hand, well, 0 is a multiple of an odd prime number because 0 is a multiple of anything, right? You can write this as 0 times 7, right? 7 is an odd number, it's prime, and 0 is definitely a multiple of that, so that makes statement E false. Okay, so yeah, it cannot be E either, so it's D as we did, as we saw here. Okay, and that's the end of the question.